Kia ora koutou. Hi everyone. My name is Mary Golter and I'm the Relationships and Events Assistant for the College of Engineering. A very warm welcome to BrainDate Sustainability. This is the third in a series of events to bring academics and industry together around a particular theme with the aim to raise awareness for what is happening in innovation and research and what the future opportunities might hold for industry. So before we get going, just a quick bit of housekeeping. In the unlikely event of emergency, please follow staff instructions. Should we experience an earthquake, please drop, cover and hold until the shaking stops and then follow staff instructions. Meeting point will just be on the grass in front of the engineering building. And for the other emergency, there will be there are toilets either side of the cafe. So we have some amazing presentations for you this afternoon. After each presentation, there will be an opportunity to ask questions, but don't worry if you don't manage to ask your questions then. There will be time as well at our networking event afterwards. And there will also be tours of a couple of our facilities as well, so if you want to hang around for those, there will be a tour for the Chemical and Process Engineering Department and also the Civil and Natural Resource Engineering Department as well. So if you don't want to stay for a tour, just stay and network with me. There'll be drinks and nibbles afterwards. So let's crack on with this. Our first speaker this evening is Professor Tom Cochrane from Civil and Natural Resource Department.
Thank you, Mary. Yeah, this is a great opportunity to share some of our research. And before I start, I just want to say that a lot of the research we do at the university is really feasible because we have a lot of students that are really keen and enthusiastic about sustainability and research in these areas. And so what I wanted to do before I start on this presentation on stormwater sustainability is just give you a little bit of background of where I come from in terms of the department I work on. I work in the Civil and Natural Resource Engineering Department, and we have a couple of degrees that we offer. One is in civil engineering, which provides the basic infrastructure in terms of structures, water supply, waste disposal, transportation, other systems, and fire. And we also have our Natural Resources Engineering degree, which is basically an emphasis on engineering from an ecological perspective, a lot of land, bioenergy resources, and food nexus, and also water resources. But the key thing that I just want to stress with this is that the work that our students do and what we teach them is really based on sustainability and providing sustainable solutions for problems that are facing in our built and natural environment. So a lot of the focus that we now stress on our students is about sustainability. So in terms of research, I was asked to give a little presentation on some of the sustainable research we do in the department, and I decided to focus this on stormwater. And so what I'd like to present is some research that I'm doing together with some of my colleagues, Ashley O'Sullivan and Francis Charters, and obviously with a series of students over the years. And I have three aspects that I want to present. One is the need for research, so a bit of information on the sources and the magnitude of the stormwater problem and how to ensure that it's sustainable. And then the second part is on monitoring and modeling, to identify what the issues are and quantify some contaminants in stormwater that we have to deal with. And the third one is on designing stormwater treatment systems, so providing some solutions to make our urban areas more sustainable. Now, the focus here on this presentation is on urban systems. We do have another focus on agricultural systems in terms of dealing with stormwater as well, but this is mostly on urban systems. So the needs for research and try to quantify the sources of stormwater contaminants and magnitude of the problem comes from understanding what the stormwater problem is. And so basically what's going on, and you will all be familiar with, is that as we develop, we have all these different surfaces which are impermeable. We have rainfall falling on these surfaces, and the runoff basically flows into our waterways. And especially here in New Zealand, all our water goes into different drainage canals and streams and so forth. Now the problem is that as you get this rainfall running off, you get also an accumulation of sediment, and you get an accumulation of contaminants building up in this runoff. And so that ends up in our waterways. And so because of that, it creates problems in our receiving environment, which is a lot of our waterways around New Zealand. And there needs to be a treatment for this, and we find that this doesn't happen very often, but now in recent years there's been more emphasis on trying to treat stormwater, and that's a little bit what I want to cover today. So stormwater sources, basically, as we talked about, are impermeable surfaces. We classify them into roofs, car parks, roads, and maybe others, construction sites and others that you may encounter. But when we look at one of the biggest problems that we have, and something that our councils and people who work on sustainability and in our waterways look at, we have quite a lot of metals ending up in our waterways. And then two particular types of metals are fairly damaging, and these are zinc and copper. And these are ecotoxic to our environment, and so basically they affect our aquatic ecosystems, and instead of having living streams, the aquatic ecosystems basically, the organisms die and then can't reproduce and so forth. So that's been a big problem, and these sources come from vehicles, they come from paints, and come from metal roofs, such as galvanized roofs or copper roofs, and end up in our waterways. And also, obviously, sediment as total suspended solids, which deposit in our waterways as well. So those are the main sources that we've focused on. There's others as well, nutrients and so forth, especially in the agricultural area that we have to deal with. But in terms of urban areas, these seem to be some of the key ones that we need to address. Now, obviously, when we look at our waterways here in Canterbury and we see them, they seem very nice and clear, but really some of them are very dead because of these contaminants that end up. So we end up seeing, whenever it rains, a lot of rubbish and other contaminants, but what we don't really see are some of the dissolved aspects in there. Oops, there we go. And that's what causes a lot of times our pollution and not being able to use that water for recreational purposes or for living environment. So in terms of the research that we've been doing, to quantify the problem, what we do, monitor, and then create a model to be able to explain what's going on, or to be able to expand our understanding of what's going on in the whole urban area in this case. In terms of monitoring, we've done quite a lot of monitoring roads and car parks. Basically, we take samples, we analyze them through different instruments we have at the university and elsewhere for these heavy metals. And we've done experiments taking samples from some automatic sampling, from car parks. We've used boards to capture all these contaminants, and also from roofs. So just to give you an idea of our problem here, so we have these guidelines that we follow in New Zealand, which are for the protection of, for example, 90% of aquatic species, and the threshold for that is about 15 micrograms per liter of zinc. And what we're seeing coming off from our roof surfaces is in the order of an average 200 micrograms per liter. So it's quite a lot of pollution coming off roofs in terms of metals. And so if we look at some other roofs which are older, much more zinc comes out of them. And so that ends up in our waterways and causes problems for our ecosystem, and obviously not sustainable for us. So once we quantify all that data, what we do is build a model. And so what we're trying to do is build a model that simulates total suspended solids, copper, zinc, and has the following features. It basically can be used in any event. So you have a rainfall event, you know how much is coming out of that from that rainfall event. For individual surfaces, roads, car parks, different types of surfaces. It includes climate characteristics, so what the climate intensity and so forth are, and obviously coefficients that relate to the climate and the type of surface that we're looking at. So the model that we've been developing, and we've been developing this model with industry, is able to do event loads, seasonal loads, annual loads, and multi-year loads, as well as individual surfaces, scale up to property surfaces, and then understanding of catchments. So quite a number of things that we were trying to achieve. And so we developed this model called Medusa, which is a modeled estimates of discharges for urban stormwater assessments. And if you see on your left side here, you have roof surfaces, road surfaces, car park surfaces. We quantify those for a certain urban area. Then we have climate parameters, the amount of rain that falls in certain storm event, pH and other indicators. And from those and the model coefficients, we're able to calculate TSS, copper, and zinc for each individual surface. And that gives us an estimated load for the catchment or for that particular surface that we're interested in. And so in terms of how this is then applied in industry, is that we've been engaging with, for example, DHI and building an online model, and this is an example of that. It's a web-based model so that councils or individuals can go into this model framework and then identify, for example, catchment. There's an example of the Addington catchment here in Christchurch. We have it all in a geographic information system database, so we know all the different surfaces, car parks, roads, roofs. And then what we can do is run the model, and for each individual surface, and in this case here I have an example of car parks, we can quantify for a particular storm event or for a particular season or for a particular year how much loading of contaminants is coming out from that surface. And so that's what we're trying to improve and develop with industry. And so there's lots of potential to be able to then pinpoint where the source is and then do something about it. Right? So then we come to the final part of my presentation, which is what to do. And so once you know where it's coming from, you have to do something about it, right? Can't just leave it there. So we're obviously in the business of engineering, so we tried to design some stormwater treatment systems, and so that's what we're also been developing. And so I just want to show you a couple examples. One is our rain gardens here on campus that we have for research purposes. And if you're interested later on after this, I can show you those rain gardens. And basically, there are 3 parallel rain gardens. What this gives us is the ability to test different treatment media within these rain gardens. And so this is, for example, when it's rained, and this is fairly recently, you see that the vegetation has grown quite a lot. But basically what we're doing is we're testing different types of media to see which one removes contaminants the best, so that that runoff that goes from the rain, from the catchment, from the surfaces, goes through the media and comes out much cleaner. And so it removes all those contaminants. We want to know what mixture is the best to do that. And so obviously with the help of our students doing analysis and testing, we've come up with some results, which this is some results for concentrations, micrograms per liter zinc. This is what's coming in, close to 400 micrograms per liter. And these are the 3 different cells that we're testing. So the one that does the best is cell A. Now cell A is interesting because cell A has what we've put in that mixture is mussel shells, which is a byproduct of just the shells from the mussel industry. And so we can reuse those to be able to actually treat zinc. So we're kind of trying to be sustainable in that matter, using basically wastes. And so then the other question is what happens with roofs. So we can deal with, for example, car park with rain gardens or other things, but roofs that have metals, they leach quite a lot of metals. So what do we do about them? What can we do about those? And most roofs in New Zealand are metals. Commercial, industrial represent probably 95%. Residential is probably up to 80%, depending on the region. And obviously these are very toxic. And the reason it's toxic is the metals that come out of roofs are in dissolved format, and that's very difficult to treat. It's not like it's particulate; it's dissolved in the water, so it's very difficult to take that zinc out of the water. And so what we've developed is a more sustainable solution, which involves using, for example, mussel shells again, and some other mixtures of treatment systems. And we've created this system called the Storminator. We're working with Stormwater 360 to commercialize it eventually and so forth. But basically, we capture the water straight from downpipe, treat it, and the water that comes out is basically cleared from the contaminated zinc that's coming through that. So in summary, when we look at a problem that we have, we can see that total suspended solids in stormwater are a major problem. They are the largest pollutants, they cause the largest loads of pollutants. Hotspots are usually roads and large car parks. The larger the event loads from are coming from very long-lasting events, and that leads us to try to do something about that. First of all, obviously intercept those roads and car parks, intercept the runoff using rain gardens or other systems like that, and try to use materials that are sustainable and that can be reused. And also, we also found that first flush, like is commonly used, is not really the solution, because a lot of the TSS that's coming out of these surfaces is actually throughout the whole event. So we just don't need to, it's not just beneficial to treat first flush, but treat the whole event. And then when we're looking at heavy metals, copper hotspots, we find them in large car parks with heavy vehicle maneuvering, so trucks and so forth. And lots of that due to brakes. So if you use copper brakes, that leaches a lot of copper into the environment. And then we have zinc hotspots, usually galvanized roofs, and those are obviously things that we need to treat. And then roof metals are primary and dissolved format, and those are very difficult to remove. And so source reduction is probably the best thing. Try to reduce it at the source, especially the issue with dissolved metals, and multifunctional treatment systems. So whether they be things like storminators or whether they be combinations of rain gardens and other treatment systems to be able to remove these. So in summary, what we're doing in terms of research, we're trying to work towards more sustainable stormwater management so that our waterways and our rivers are devoid from contaminants that we think are very damaging to the aquatic environment. And as I mentioned before, none of this can be possible without the real enthusiasm of our students and all the hard work they put into this kind of work. Thank you. Any questions?
The mussels, so that just filters it out, or does something else happen?
Yeah, it's very interesting. We've been looking at what the process is of removing dissolved metals with mussel shells, and they can absorb to the surface. They can also internally absorb through the matrices of the mussels, but they change the pH of the water as well. So the pH change because of the calcium carbonate causes basically the metals to coagulate and drop out of solution as well. So there's a few processes that are very interesting to look at as well.
How many, in an average rainfall, how many litres of water would fall on an average house roof? Like say a 1 hour rainfall?
Yeah, so it depends on the region. So for example, in Christchurch, we normally try to target rainfall that is, let's say, 10 millimeters per hour, and if you have 100 square meter, then you can start calculating the volume. And so it depends on what you're trying to target and what is your target rainfall, maximum rainfall event.
That little box here with the mussels in it,
Yep.
how many mussels would you need to treat to rain that volume?
Yeah. Oh yeah, so that's interesting. The box basically is a flow-through system, so it doesn't matter how much it rains, it'll just flow right through it. And it's just an interaction of the water with the mussels that removes it's like a filtering system basically. So you don't have to hold it there. Whereas some of the other systems that are more, holding tanks, then you have to hold it, and then you would be worried about the volume of water. But in these systems, it's basically a flow-through system.
So that particular size box of the mussels,
Yep.
what's that? How many litres a minute is that designed for?
We've designed it to deal with up to 20 millimeters of rainfall, and then if it's beyond that, then there's an overflow for that. But we also designed it that we have actually different cartilages in there. So if you wanted to treat much more, or you're looking for a very large storm event, then you could put multiple cartilages, and that'll work as well.
So that particular picture of the mussel fins, the percentage of contaminants coming off the roof, how much filtering does that actually achieve? Like, does it achieve? Is it take out 50% of the contaminants?
Yeah,
1%?
so what we're targeting is about 85% of the soil metals. So that's from our experiments to date, that's what we're seeing. Sometimes if we have smaller events or large events, that obviously varies. But we're trying to achieve that.
So how many mussels in that box there?
Yeah, that's a tough question. I don't think I can answer that one, but that would be close to probably 60 kilograms of mussel shells.
So it's powder.
Hmm?
It's powder.
Yes. So the secret there is on the sizes and the so it's not just the actual mussel shells. It's how you break it down. The range of size crushed, and there's also mixtures with other materials. So there's zeolite. There's for example. Limestone and so forth that can be so that's where we're working to get the best mixture that will remove as much as we can in terms of pollutants. Sorry, yeah.
Lifetime, how long it takes for it to get saturated, and what do you do with the accumulated?
Good question. Yeah. So the initial target is at least 2 years for the system, but again it varies on storm and concentrations that you're looking at. And then the question is, what do you do with the stuff after? Because we want to be sustainable. So there's two options that we're looking at, and we've tested. One is you can actually build concrete out of mussel shells and limestone and so forth. So you can convert that to concrete, cement, and then obviously concrete. Or you can turn it into fertilizer. So for areas or land that needs zinc as a micronutrient, that can also be used for that. And since it contains a lot of calcium carbonate, that is also kind of like liming. So it kind of goes back through the whole cycle without wasting that material. Great, thank you.
Thank you. Awesome, thanks so much, Tom. He will be doing a tour as well afterwards, so if you wanted to see the rain gardens or the Storminator in action, just have a look out for Tom afterwards, and he will be able to show you around. So next up we've got Professor Richard Green, who will be talking about artificial intelligence enabling automation to accelerate sustainability.
Great, thanks. Hi, so a bit off the wall in terms of sustainability. So it's not your traditional sustainability topic, but we've been doing a lot of research in AI, computer vision and automation, and it's made me realise that the research we're doing is very much informing the future of the possibilities, because one of our problems in sustainability is how to scale up, because we're very much constrained by the human resource, whether it's spraying wilding pines or whatever. And so I'm from the Department of Computer Science Software Engineering, where we do a lot of work on autonomous control of drones, robots, underwater drones and so on. So we cover quite a wide range of areas already. That's a bit fast. And it's really interesting the extent to which the algorithms have improved in recent years. Like going back 10 years, even 5 years, most conferences would be talking about perfect control conditions in laboratory environments to reliably automate things, whereas now we're getting really high accuracies in the 90% for recognising and doing some really robust commercialisation of products. So that's really making a big difference. And the quality of the sensors, the cost of sensors and the cost of processing power, all these things are converging into enabling, from our perspective and the research we're doing, that within decades, any mundane, repetitive manual labour task outdoors, we appear that we can easily and cheaply automate this. So it's just the direction everything's going at the moment. And I remember when I got one of my first projects for automating grapevine pruning, about 3 mil from the government, and all these journalists rang up and they said, "Oh, you're just going to create a whole lot of unemployment." And I sort of reminded them of this bit down here, back in the 1800s, most of us were living on the land, and go forward a couple of hundred years, and most of us are sitting in front of keyboards and screens, and we're not massively unemployed as they would have predicted a couple of hundred years ago. You know, like we should be all dying of starvation because we're not working on the land anymore. So it's yeah, we adapt. What was interesting is not one single journalist actually mentioned in the article that this was causing unemployment after that discussion. And so I thought that was interesting. So one of our projects has been using drones to prune trees, because like one of our third largest industry is pine forests, and we have planted them on land that's so steep and rugged that with big holes and boulders that half of the area of our pine forest you can't even get a ground vehicle to. So we thought, right, how can we automate this? So the government was crazy enough to give us $1 million to weaponise a drone with something that cuts branches. What could possibly go wrong? And it actually worked, you know, which was quite nice. It's involving a lot of different areas of research: mechanical, electrical, software engineering, and so on. And from this, it sort of gave us a few ideas of how we could massively automate this for swarms. So here's just an example of it running inside. You'll see someone running around the background with the emergency stop button, because this is, you know, like very much experimental software. At any moment, it could pole drive into someone's face through that net there. So, you know, we're very much trying to, you know, have good health and safety controls. But this is completely just autonomously controlled, even though it looks a bit jerky and random. There's no human involved in that process. So from that, so that was an MB, and then more recently we did a SIFTI project, so Science for Technological Innovation, on looking at harvesting trees. And even then we could see, okay, you could actually use drones to harvest trees, and also to the maintenance on trees and so on. So it was really interesting to see the extent to which we could use swarms of drones, even on a more recent one that we're working on right now, which is planting trees. Because it's one thing to use all these planter bots, and everyone's getting on the planter bot bandwagon these days. It's another thing to actually get them to very inaccessible locations. So we've been looking at, you know, swarms of drones using that kind of technology, which of course is very relevant to sustainability, because we want to plant all these trees in New Zealand. There's only so many people available. Unemployment suddenly didn't skyrocket like we thought it would after COVID-19. So there's just not that many people available to do this for us. So that looked like quite a reasonable approach, and it's been going very well with the SIFTI project. Another thing that's just come out in the last few weeks, and I thought, I came across it today, I must put this slide in, where they've got a 20-litre tank, and DJI's come up with this, about 10 grand, so it's not ridiculously expensive, which can do really large area spraying. And so we've had a number of projects, and even mechanical engineering has had involvement in spray dispersal technology. So there's a whole lot of people, various organisations involved in spraying wilding pines, and at the moment it tends to be helicopters dropping off people with chainsaws or sprays, and the problem's just become so bad, you know, like at Central Otago, that you just could not get the manpower to actually get rid of every single wilding pine. So we have to think, how in future can we scale this up to automate it? You know, so we've done things like surveying and doing path planning, and then thinking about what the optimal path is, considering the tank is getting lighter, and a whole bunch of other stuff to figure out how we can do this with swarms of drones, because that's quite a severe problem in New Zealand. But it was just interesting to see what's just come onto the market now. And I'll put this here just because the cost of the hardware I didn't mention before, the actual physical hardware, has really come down a lot. And so we're, like I said, that DJI drone, little robots like this for a couple $100, and we've got a big metre by metre one that's racing around that was about 5,000 that were instrumented. So just the cost of the hardware and the reliability is improving so much. So it's enabling us to get out to a lot more places than we could have in the past at a much more affordable cost. I mean, we still need the mechanical engineers to basically customise it, but it's really giving us a huge head start in getting a lot of research done. Another area is underwater drones. So we've got a really advanced autonomous underwater drone research group in this university. And that was, I started years ago thinking, I'll use this about 10 years ago, looking at biofouling on underwater surfaces on ship hulls. And I thought, how hard could this be? Until I realised how turbid the water was. And so then I had to go really close. And that means I had to have a really wide angle lens. And that meant that I got refraction from salt water, glass, air, camera, where the blue pixel ran about 13 pixels away from the red pixel, and which would have been fine, solve that with optics, except it varies depending on salinity and temperature of the water. So, so it took us about 4 years with a really great PhD student to just crack the maths for that, to figure out how to undistort that. And we finally made it, and so we've been making some very good progress in recognising biofouling on ship hulls, and another SIFTI project I'm involved with is on mussel farms, biofouling on mussel farms, and trying to detect other particle matter in the water, because we're getting down to 0.1 mil 3D surface reconstruction accuracy. So, we're actually doing some really good real-time analysis in both recognising invasive biofouling species and other elements in the water. So that took a long time, but it sort of does help inform the future of where we could be going in sustainability in respect to that. Another area of scallop beds, where traditionally drag a big chain net behind, completely wreck the ecology of the seabed. They just totally destroy it to collect the scallops. And now we're working with a project, the other one that I mentioned, the underwater drone one with mussel farms, that was with Cochrane, Nelson, and the scallop bed one is with NIWA. And so we're using this to use underwater drones to scan the seabed, and we're working on a project with them where basically you have a robot arm going down, so this is with Mike Hayes and mechanical engineering, going down and sucking up just the right size scallops. So all you're lifting off the seabed are the scallops of the right size and nothing else. But we're a bit different over here with our scallops. In Europe, they're nice and easy to spot. Here, they try and cover themselves with sand and make themselves invisible. So here's sort of a few more clearer ones. And about the only thing you really see around them is, the feelers of the mouth. So quite often this looks exactly the same as the sand around, except for all this little feelers going out. So we've been making some really good progress with deep learning to actually recognise it, as well as a human diver could just swimming along. So we've made some really good progress here. This is just sort of a ground truth with little markers to show where we had divers go and actually measure them and so on to give us the information. So that's been a lot of really good progress. And in some places in New Zealand, it's done so much damage, the government's just banned farming for scallops. I just threw this in because one of the areas we're using drones is in Antarctica, which is lovely because you can see for a kilometre underwater. It's like being in air. And they're rebuilding Scott Base, you've probably heard about that, and they're very interested in the impact of the ecology. So because we've got autonomous drones that can just automatically scan the seabed in a predefined pattern and do it like week after week, then they can look at how everything's changing there to understand the impact on construction in such a fragile environment. So that pretty much wraps it up, so thank you for your attention.
We've got a few minutes for questions. Any questions for Richard?
Hi, Jason. How do you get the RTK corrections to the big drone that's taking out like a whole tree? How do you get the RTK corrections to the drone?
Right, good question. So there's two answers to that. One is, of course, Trimble has this network right across New Zealand, to get it down to centimetres rather than metres. But the other one is that generally, where we're looking for them, out in the countryside, they're not all crowded together. And so we're actually going approximately to where they are, and then we're using the camera, and we're recognising it, doing deep learning, and then having it be within about 0.5 metre of the top, and then spraying it from there. But if they're really dense, they just spray with a plane. Yeah, good question. Yeah.
Richard, just very fertiliser you talked about, what's the composition?
Sorry, the fertiliser?
Fertiliser you talked about?
Fertiliser.
Oh, I've got from the last meeting.
Oh, yes.
There we are, doesn't matter.
Yeah. All right, good. Oh, that's a relief. I was going to think, I don't know the answer to that question.
Yeah, I can tick that one.
Phew, good.
There'll be one for Tom afterwards. I
Yeah,
think.
yeah.
Awesome. Well, thank you very much,
Yeah,
Richard.
okay, thank you.
Obviously, you'll be sticking around afterwards for any
Yes.
further questions. Awesome. So, brilliant. So next up, we've got Daniel Bishop, who will be talking to us about small ideas.
Thanks, Mary. Just put my timer down there. How we going? Cool. Firstly, thank you to Richard. I think that was the best advertising for mechanical engineering, and that's where I'm from. So I'm Daniel Bishop. I'm in mechanical engineering. I work as a project engineer. Also, I've been working on a PhD for a few years. In the last stages, and kind of putting this presentation together, I've been desperately trying to avoid thinking about my PhD, so I just kind of parked it with some other ideas. So I've been roughly in the energy field for 5 years in research in the areas of building energy, transportation energy, and I'm lecturing energy systems engineering, so NME 405, 605 if you're interested. If this ticks some boxes for you, enrolments are still open. And so what are we going to talk about? Big ideas, a little bit on my research, just a slide, and some projects pitch. Okay, so I've got a question for you guys. Sustainability, what images come to your mind? Say you wanted to run an industry academic event and pull people together from all over the show. What images would you crystallise the event with? Greenery. What else? Reuse. Well, I mean, that'd probably be a good one. What's synonymous with green stuff? Solar. Oh, there we go. Mary, look at that. Solar panels. And it's funny because it's true. When we look at the advertising and the ideas people have around sustainability, they tend to nucleate in very particular areas. And solar, and you've got a marketing background, eh? Yeah, totally. Looks really pretty. But if we're going to be honest about sustainability, maybe we wouldn't necessarily be putting as much weight in solar as we do. Maybe a hydro power plant or something else there instead. So I've always been kind of curious as to why these things became as like sticky as they have. And because it's not just this, it could be solar, electric vehicles are a big one. You have enough conversations over the years in kind of research context or conferences, or just you talk about your research, which I try to avoid, but and these ideas always come up, and it's amazing how kind of sticky they are. So electric vehicles, offshore wind, solar roads, hydrogen cars, hydrogen fuels, the smart grid, through fusion in there. It's not as common, but when you're talking with students, that always typically comes up. And it's interesting to me because these things have become synonymous with energy, synonymous with sustainability, but if we're going to be honest with ourselves, there's usually some pretty good reasons why we don't do these things. There's usually a lot of context between what makes this feasible and infeasible, just like how sometimes, where's Richard? It's a sticker where people will throw AI on something where it's completely irrelevant to the area. So we all see it. And to be honest, with the energy field, I do see it happen even with well-meaning, educated people. So we look at this in NME 405, 605, so second pitch. And why I've always wondered why these ideas are so sticky, and we're going to blame Elon Musk. I've wondered why, because there are some things like reuse that could be far more effective, but they're not as sexy, right? So what is it? What is it about these things that are really stuck in people's minds? And I think about it. I heard Jonathan, you said the story earlier. And more people, we're starting to become aware of, it's not necessarily the facts you're looking at, but the framing of the facts and how things are delivered and how you package it. And people don't respond necessarily to facts, they respond to the story you package it in. Right, and so I think that's kind of what we're living in, is the technological frame. So the 19th, 20th, 21st century, we've had amazing innovations in technology in the energy field, and this is just kind of transportation, but you could put that across so many fields. Medicine, and this isn't me beating up on technology. I'm an engineer, so I'm kind of stuck with it. But each problem that came up, there was technology was kind of there as a solution. But it doesn't mean that that's necessarily going to be the solution in the future, right? And I would say that more and more it's not living up to our expectations of it. So if we're projecting forwards in our heads and we're going to colonize Mars, flying cars, maybe not. All right. So why is it a problem? Because if technology works, it works, and it does work. And in so many cases, it's really applicable. But at the moment, particularly in the energy field, this just sucks up all the air. There's a monopoly of attention on particular ideas that mean you don't actually get time to talk about some small ideas, small little practical things that actually work. And there's easy ones. And because everybody's looking at the big ideas, I think there's a lot of opportunities to focus on small things that might not make the world-saving difference in and of themselves, but are worthwhile to do. And I think we don't necessarily help with this in academia. We try to sell, right? So if you can pitch how your research is going to be the best thing ever, but then it becomes really hard to discern, because if everything raises to the level of the most important thing, how do you discern what's important anymore? You don't. Right, there's no proportionality. All right, so I'll talk about my research for one slide. So my research is a small idea. I think all those previous slides were a justification as to the existence of my research. I've been looking at buildings and lighting, whereas LEDs, there you go, technological frame, have improved the efficiency of delivering light. I've been looking more at how we design lighting. How do we utilize it? So can we use it better? And the current methods aren't particularly good. We look at light on a horizontal surface. Well, we don't actually see light on a horizontal surface. We see contrast. We do see light levels, and it doesn't matter how that light is distributed within your field of view or your vision. So we really actually care about visibility and brightness perception. We don't care about light levels. So what I've been doing is looking at two ways of kind of going back to the actual utility. How do we better deliver light based on how we see? And the answer is lighting distributions. We have these amazing sensors now, cameras in our phone, that we can actually use to characterize into luminance imaging devices where we can capture how people actually see. Now this hasn't been reflected in industry yet, and I think there's a couple of reasons. One, the price of these devices are huge. Commercial ones are about 30K. We've managed to get them down to about 100 with the same utility. And they're also, it's a chicken and the egg. So even if you bought one of these devices, how would you apply it? So there was no theory for application. So why buy a big, expensive device if you had no way of using it? All right, or to design too. So the standards were a bit of a barrier. And we've got some fairly good results. I mean, you can pretty easily cut 10% of your lighting use just by distributing it differently. So distribution does matter. And then if we were to actually look honestly about how much light we need for performance, you can easily cut 30. And then if we were able to better integrate natural lighting by not just looking at replacing horizontal illumination, but looking at the distribution of light, there's certainly times in the day you could cut it all. I will say, just back to the small idea, this is why I don't talk a whole lot about my research. Man, it's a good way to kill a conversation. What do you do for your PhD? Lighting. So I've had a few conversations like that. And like I said, I'm going to pitch a couple of projects that moving towards small idea projects. In mechanical, we have final year projects. I don't know if they've been introduced to the final year projects. So since you guys are industry and I have you here, I may as well pitch them. 4 final year students will work full-time on a project, either something you suggest, the intellectual property I believe belongs to you, at relatively small cost. And I'll pitch a couple. So we hear a lot about hydrogen, and there's a kind of good story around hydrogen, is that the most effective renewable resources we have, right, are on the table of wind. Hydro, we can't scale too much more, but wind, there's plenty of it. Where do you put stuff? But because it's highly intermittent, we can't integrate it into our grid easily. Even where they've done lots of it's typically where you're not landlocked, so you can sell it to other countries when the wind's blowing. Right? So naturally we say, hey, we need energy storage, and then it flicks over to hydrogen. So hydrogen can be used to store and transport energy. So it sounds good, and therefore we're renewable. But I'll be honest with you, there's a lot of reasons hydrogen hasn't taken off. There's some technical issues, and there's also, it doesn't necessarily compare as well to the existing options we have. So kind of going back to the question of what is the problem we're trying to solve, we actually need not to create a new economy around hydrogen. Necessarily, maybe we do, but we need to affordably integrate greater levels of intermittent generation. Right? That might be a bigger, better question to ask. And if we're asking that question, we can do it in other ways, and maybe not the most kind of sexy, revolutionary ways where we're all, doing that. But your hot water cylinders. So demand flexibility can have the same effect as energy storage, in that we can shift and call on demand. It's not revolutionary. Night store heaters, night switches, some of these things are already used. This is one of the projects I'm pitching. So I kind of call this the second dumbest smart controller for hot water cylinders, because smart devices gets played up a little as well. So this is the second dumbest. It's a retrofittable controller for the hot water cylinder, and based on some nearly everybody's got electric hot water, right? So some vague calculations puts it at debatably one of the largest energy storage programs the world has. And instead of the, if you're looking at battery energy storage or compressed air energy storage, which are quite expensive. Energy storage is expensive. That's one of the key problems. If we're talking about $20 a kilowatt hour, it's ridiculously cheap. If what we're doing is just using things a bit smarter. All right. And how do we do that without compromising utility? There was the distinguished Professor Jeff Chase, did a lot of work on insulin dosing. There's unknowns about how people eat, there's unknowns on how people react to insulin. If you apply the same sort of theory to your hot water cylinder, you can guarantee utility. So, we've got a couple projects like this ready to go. One is the hot water cylinder, one is a similar thing that maybe has a bit of commercial sensitivity around it, around commercial refrigeration. If you want to pick these up, feel free. Just come see me or Mary or somebody, or Graham. All right, that's me.
Any questions for Daniel?
So you were advocating for utility, for increasing the utility of light over the efficiency of light. You were saying that you could get a 10% increase there. However, changing from fluorescent to LED is going to give you a 50% increase, or from incandescent to LED you're going to get a 90% increase.
Well, yeah, but you can do both. So one, you can do both, and two, kind of commercial LED stuff available isn't necessarily going to give you a 50% increase. I think sometimes the ratings are a little overstated. Where they're comparable with fluorescents, they're better for sure. And one of the best things about our LEDs is you can dynamically dim them, right? Like right now we can pull this down to 50% without losing tons of energy in our controllers.
Well, no, I would say the best thing about them is that they basically last for 20, 30 years.
That's awesome as well. Yeah, I'm not ragging on LEDs. I'm saying let's lots of people are looking in that direction. Let's look in this direction.
But while looking in that, we need to keep looking in that direction.
Totally.
That's where our majority of savings and increases are going, right? That's a small increase.
Well, how do you? Well, that 10% was the first one I said, and incremental or stackable. And how do you know what you're missing out on if you're not looking? So until I kind of came along and said, oh, maybe if we're designed to lighting distribution, you didn't know that 10% was on the board. And I don't think we have as many progressive gains in LEDs as people kind of think we do. Usually it's, what do they call it, the sun distribution. You get most of your easy gains early on, and then progressively you do get better, but you don't get as good as we like to think. 100% agree with you. Worth pursuing, also worth pursuing this other stuff.
Your research is dangerously close to business model innovation.
Uh-oh.
How do do you scale small things is a business model question more than it is a engineering question. And that to me is sort of like, because I grew up on an organic farm, and the conclusion I keep coming back to is like, we should just be doing local markets if we wanted to produce sustainable outcomes. I find myself in software, different business models, and solving problems at small increments. So, yeah.
That might be worth looking into, is that what you're saying?
But, like, things are in the wrong building.
There's a really cool book called Range by a guy named David Epstein, where he kind of tries to gives people a justification for late stage career changes. And I think a lot of people find themselves in that thing where they've studied one thing their whole life. They're like, you know what, maybe I'm actually an artist. Or maybe I want to go back and be an organic farmer, which maybe that would be a good idea. Yeah, awesome. Any questions? I'm sure somebody was going to push back on the hydrogen.
Well, I can tell you the business model around decentralized hydrogen, but that's different.
Sounds good. Awesome. Thank you guys so much. Appreciate it.
Awesome. Daniel will be hanging around afterwards as well if you wanted to ask any more questions or push back on hydrogen.
Yeah.
Daniel mentioned as well the final year project in your goodie bags that you got. There is a final year project booklet for 2020, which kind of gives you examples of what can be done with the final year projects, and there's contact information at the back as well if you wanted to get in touch about that. So next up we've got Associate Professor Aaron Marshall, who will be talking about extracting value from waste.
Thank you. So I'm an electrochemical engineer, and Daniel will love that some of my research is on hydrogen, but I'm not going to talk about that. I'll talk about the stuff relating to extracting value from waste materials. So this is sort of my overview of the sort of research that I'm involved in. Because I'm an electrochemist, I've got to do electrochemical engineering, including CO2 back into fuels and large-scale batteries. But my waste extraction projects are largely around metal recovery, and we've got 3 projects, so I'll just sort of touch on those. So titanium from waste slag. So New Zealand Steel has a fairly unique process around the world to make steel, in that we take iron sand off the beach, and we throw it in a big kiln, a massive thing with a bunch of coal, and it reduces the iron in the sand, and then it goes into a giant big melter, and the iron falls to the bottom, and some slag floats to the top. And then this slag is the iron's tipped off and sends to steel production, and the slag is put into a big bowl. So that big bowl eventually gets tipped out onto the ground. It's quite impressive, and basically rocks form, and then they crush it up and they put the slag, this waste material, on roads as aggregate. Sometimes underneath it's real cheap. So of course all this material has come from the sand itself. So anything that's basically not iron ends up in this stuff. The interesting thing is that New Zealand iron sands have a lot of titanium in it. So the slag itself contains about a third titanium. And we had the crazy idea of trying to get this metal out, because we thought titanium's worth a hell of a lot more than road fill, basically. And the interesting thing with titanium, with the first production process was by a New Zealander. He was working in the US, but the Hunter process, basically you take titania, throw in some sodium at high temperature, and it reduces to titanium metal. And then another process came along, the Kroll process, which is super, super nasty. It's like if you were designing a process and you wrote down the steps, you'd go, there's no way in hell I'm going to do that. But that's the current process, which is why titanium is really expensive. Because it's like the 7th or, 7 to 10th most abundant element on Earth, yet it's really expensive. So we thought, what could be more interesting than trying to extract this titanium? So our idea was, rather than tipping that stuff onto the ground, was put a couple of electrodes into it and electrolyse it while it's hot. So basically we're going to run a current through molten lava type stuff and see if we can extract titanium. That was our idea. Turns out it's a little bit tricky. For a start, the stuff doesn't melt until 1600 C. So, ironically, building or having a furnace in the lab to operate at those temperatures is quite challenging. We can do it and we can produce titanium, but most of our work, because we needed to understand the fundamentals of how do you electrochemically reduce a molten oxide. It's kind of like the idea of the aluminium production where you electrolyse and make aluminium in a molten material, but there it's a molten salt where the aluminium's dissolved. In a molten oxide, it's not so clear. So we ended up doing research at MIT, and basically what we used is I call it a death ray, and we basically have a stick of the slag, and we have these giant xenon lamps, and we focus the light down onto that tiny point. So it's about, you can kind of see it there, it's not a very good image, a little lump of slag, zap it with the light, it melts. If you turn the lights up too much, it just disappears. And then we shove some electrodes into it and do electrochemistry in there. So we can go up to about 2000 C in this system, but our material sort of was max about 1900 Kelvin. And sure enough, we could deposit titanium on the electrodes. And we've done it in our cell at UC, and we can produce titanium. The catch is we also produce silicon at the same time. So we produce a titanium silicon alloy. And we're working on some other ways of avoiding the silicon, because you don't want the silicon in there. So in theory, it's possible, but tricky. So another related sort of project, again, electrochemistry orientated, and it's sort of related to what Tom was talking about, is zinc recovery from waste. So in the galvanizing industry, before they put a nice coating of zinc on a piece of steel, they dip the piece of steel in a big vat of acid to remove all the old stuff. And eventually that acid contains lots of iron and lots of zinc. So up to 7-8% zinc. So it's a huge amount of zinc. At the end of the day, when that gets saturated, they're going to tip it out and they get rid of it. What they normally do is just throw a bunch of lime in there and it all precipitates, and they pick up the sludge and throw it into landfill. And Tom was mentioning the sort of discharge or the safe levels of zinc. Of course, if you've got a big pile of sludge sitting in landfill, it leaches out. So it's nasty stuff. Even though I was kind of interested in the idea of preventing the environmental damage caused by this stuff, I just saw the dollars. Because inside this waste is a huge amount of value. So currently galvanisers pay, well, it varies a lot. It'd be helpful if the government did something about this, but between $200 and $1,200 a cubic metre to get rid of in New Zealand. And I haven't got the numbers there, but there's a lot more value if we could recover these metals from it than in the disposal costs. And so we've developed a process to do this and founded a company to start exploring this idea, and it seems to work. So the really nice thing is you can essentially just separate, the original waste is formed from these three components. You take acid, iron oxide, that's sort of rust and steel, and zinc. So all we're doing is driving the process backwards to try to split these components back out and add some value. At the moment, we're in the stages of building a pilot plant. We're doing this on campus. We've just employed 4 people to sort of do the grunt work. And hopefully, sort of end of the year, we'll be looking at designing the full-scale plant for New Zealand. The interesting thing in New Zealand is we've got like 13 galvanisers. So in theory, we could probably do the whole of New Zealand in a relatively small plant. So it would be an interesting thing to see if we can pull that off. The last project I want to talk about is one I set up with GNS a while ago. And it was largely came about because we had a student who was really interested in this. And it was the idea of what to do with lithium-ion batteries. So we know there's stacks of them, and there's going to be more and more and more of them. And the big problem is, once they're dead, what happens to them? And there's a really interesting problem in that over time, the flavour of these lithium-ion batteries is changing. So the early ones that we throw out are different from the ones that we'll throw out in 10 years' time. So it's a significant problem. In New Zealand, this is some calculations we've done, yeah, there's going to be a lot of, this is, I think it's, yeah, thousands of tonnes of lithium ion waste. So we're getting up to 50,000 tonnes of lithium ion waste. So it's going to be a huge, huge problem. And what do? Can't just send it off overseas anymore. So what we did to start with, we thought, could we just reuse these batteries? You know, the dead-ish. Could we reuse it? So this was the first project the student tackled. And we basically bought a bunch of dead laptop batteries and ripped them open. And inside the dead laptop batteries, there's just smaller batteries, if you like. And then we just tested them to see, do they still work? So we tested a couple of hundred cells. And surprisingly, most of them are perfectly fine and can be reused. There's a few dead ones, and of course the reason your laptop battery dies is the dead one causes the problem. So we went and built like a Tesla power wall out of these things to test it out. It's sitting up at GNS at the moment. But there is a problem with doing this. It's a lot of work to pull these batteries open and then reassemble them, test them, and all this kind of stuff. So we ran charge-discharge tests on all of them to see, you know, if they look good, are they good, things like that. So it's a huge amount of work. So you could do it in your garage and build yourself a power wall, but it's probably not something that we should do large scale. So we thought, what about the value stored in the material? Could we just extract the value and look at it like that? So this is just a breakdown of some typical cathode scrap. And there's a hell of a lot of value in lithium-ion batteries. Most of it's actually just the metals that don't do much, like copper and the electrolyte. But you know, some of the metals are quite interesting. And then some of them, the cobalt, for example, is a really interesting one because it's a critical resource. It comes from the Congo and is a serious problem. So lithium-ion batteries, people are trying to reduce the amount of cobalt, but in the future we're going to have to extract this. So we did a bunch of experiments. It's pretty crude to see if we could actually extract these things. This is a major challenge because the batteries are so complicated on the inside that you can't just, or if you do just chop them up, throw them through a shredder or something, then you've got all the bits mixed together and it's hard to separate. So in this case we were being a little bit more careful, like unwinding the copper strip and things like that. And then we did a series of tests to see if we could extract the value. And we could normally get about 90% of the valuable metals out pretty easily. We developed a little process, and then the students now developed a bigger process, don't need to know the details, so that we could imagine, could we conceivably make a system in New Zealand to extract value? Now the big challenge is these batteries come in all different sizes and all different shapes, and so dealing with that sort of complexity means the process is really tricky, because it's got to basically take every type of battery. And then, of course, the consumer doesn't really know if it's a lithium battery or not, so they'll throw a few alkalines in there. So, yeah, it's a major challenge. So that's the sort of thing that we're working on in the waste recovery process. And what I'd say is I look at a lot of waste as being sort of a resource rather than an actual waste. And lots of waste streams contain lots of money, and they could be managed quite well, but the problem is the complexity of the waste. So we either have to develop fancy methods to deal with the complexity, or we have to ask the people who make the waste to avoid it. So the classic is in the galvanising industry. The reason the big tanks of iron and zinc is because they put the steel into the same tank. They could put it into different tanks, and then you've got a simpler waste to deal with, and then the process would be simpler. But unfortunately, that's not the way things work. In the case of lithium ion, where we're trying to pull out cobalt, so we don't need to go to the Congo, they put a whole bunch of other elements in there, small amounts, but there's heaps of them in there. So eventually those things have to be separated, and that's going to be a major challenge. So that's all I've got, and thanks for listening.
Anyone got any questions?
Cool.
Oh, cool. Brilliant. Thank you. Awesome. So up next we've got Dr. Matt Morris, who's our Sustainability Advisor here at UC.
Kia ora koutou. Cormac Morris, Toka Wingwa. It's lovely to be here, and thanks so much, Graham and Mary, for the invitation to come along. I'm just going to talk very briefly about what the Sustainability Office does at UC. But I thought first it might be just good to take a moment and think about what sustainability is, and to come back to that point that Daniel raised before about what's the problem that we're trying to solve. I'm not going to go on about this too much, but normally when I'm talking to groups of people, whether they're school children or professionals like yourselves, and ask the question, what is sustainability? All kinds of answers come back, but they seem to be able to be kind of categorized into three areas, which may say just more about their kind of general perspective on life. Because the first group seem to be, you could say that their goal is to leave the world only a little bit worse than when they arrived on it, right? So it's a kind of pessimistic view. The assumption is people will always have a negative impact on the world, but we should perhaps just try to minimize that negative impact. The second group are the people who would say we should leave the world no worse than we found it. So, which seems very optimistic, I think, at the moment, given the state of the world. And then, of course, the third group are like, no, we should, our goal is to leave the world better than we found it. Humans can have a positive impact on the world. So I'm not sure where all of you might put yourself in that scale or taxonomy, if you like. But I'm hopeful. I'm thinking about that last one. We have the ability to leave the world better than we found it, and it's cool to hear so many good examples of that this evening. At UC, we have an idea in our minds of what we mean when we talk about sustainability. I'm talking at policy level, and I didn't have a diagram of this, but does this work? Okay, I'm going to try to quickly draw this, and this is courtesy of one of our great engineers in Cape Chemical and Process, Dr. John Peat. I'm sure many of you will have come across him. And he talked about a model of sustainability that is called the triple bottom line model. You know the one? So where you've got, there's three circles. They're not meant to look like that, actually, are they? I just ruined it now, haven't I? So, I'm dreadful at these Venn diagrams. Now I've wrecked the whole thing. But anyway, here we go. So, one is the environment, one is society, and one is economy, and the bit in the middle that's meant to cross over that doesn't in my diagram is where sustainability is. So that moment where the three come together. And what he said was, actually normally what we end up with is this giant economy and these two, environment and society, which he says, therefore, the triple bottom line model is, you could also call it the Mickey Mouse model of sustainability, which is quite nice, isn't it? At UC, we have we took his idea of strong sustainability, which is where you've got the economy in the centre, dependent on a strong society, which in turn is dependent on a strong environment. So this is what we kind of go with. In theory, so that's our policy kind of framework, which I think brings me to this chart, which you may not be able to read, but I can talk you through it. Over the last couple of years, the university has been through quite an extensive consultation process around developing a new university strategy, and it was so encouraging for me, who's been here for more than 10 years in the Sustainability Office, to see that there was so much feedback about the need to include some environmental parameters in thinking emerging out of that consultation, that a whole kind of chapter was developed around environmental sustainability, which is what this bit is. So So the overall university strategy is an engaged, empowered, is that we'll be engaged, empowered, and making a difference. And under that, there are 5 goals, one of them being environmental sustainability. And I'm just going to kind of talk through these 5 areas of the sustainability, of the strategy, so that you can get a sense of what we're trying to achieve here. I should just say that the Sustainability Office has been in existence here as a Sustainability Office for 11 years now. And I've been there for the whole of that time, but there was about 10 years before that where we had an environmental officer who was mostly focused on what universities used to do in their sustainability planning, which you could also call campus greening. So taking care of our energy, our waste and transport and that kind of thing. But I suppose if you think about what's the biggest opportunity that a university has to make an impact, to leave the world better than we found it, there might be lots of answers to that, but one of them is our amazing students and also our wonderful academic staff and the research that they're conducting. So, but we have this army of students who potentially will go out into the world and completely transform it. So this bit about this first one here, the title's not very clear, but contributing to resolving the Sustainable Development Goals. That's basically about ensuring that sustainability messaging is woven throughout the UC curriculum. And we're in a good space with this already, I think, because you can find sustainability-related papers in most of the colleges, most of the departments even. We're focusing on engineering today, obviously, but in sociology and law, even in fine arts, they do projects related to sustainability. I probably shouldn't say even in, but I've even heard, oh, there I go again, music, So that's this one. The thing that we've been able to do, like I was saying a little bit earlier, is we've got breadth. Sorry, there is that breadth, and within the disciplines there's depth. But what we don't have yet, and I think one of the sort of struggles that we have is to figure out, should we have a kind of single sustainability curriculum? Should there be a degree in sustainability, And it's an open question probably, because how do you get both breadth and depth? And if you're trying to look at all of these things, how would you structure a course that could deliver a sustainability professional who can cover all those bases? So it's a question. The next one is around research. So ensuring that our research contributes to global sustainability goals. We've heard some good examples of that already today. The third one is causing us all a lot of perplexity here at the moment. It's a good goal, becoming carbon net neutral. And the date on that is 2030. But you may recall that the government has just released its statement that the public sector should decarbonise by 2025. Universities are kind of exempted from that, but obviously we want to. So we're looking at what are the options for UC to decarbonise and become carbon net neutral, and I'll just talk a little bit about that in a second. The fourth one there is improving environmental sustainability. That's back to the traditional greening the campus. So we're still doing those things, and that's what I get to focus a lot of my time on, reducing our waste, improving alternative transport options here, working with Tom and his team around waterways restoration. We have 3 streams on campus, but we focus a lot on one of them, and making some good headway there. And then the fifth one at the very end is growing our sustainability networks, and I want to also talk about that just a little bit as well. So, yeah, so on the carbon, just to note that UC was the first university in the Southern Hemisphere to adopt CMARS, which is what was called CMARS, Certified Emissions Measurement and Reduction Scheme, where I think there might be another couple now in New Zealand who have jumped on board. This is a run through Toitu, so now it's called Carbon Reduce. So basically it means that we've had our emissions audited and verified by a third party. And this, so there's some goals in there, the 34% reduction in emissions already achieved a couple of years ago, and most of that being through just efficiencies. But this is, the most important thing, I guess, in the carbon journey is to understand what the carbon profile is. So I've just put it up here so that you can get a sense of what we face as an organisation. Most, by far, of our carbon emissions come from the fact that we burn coal to heat our buildings. And then a little bit behind that is our air travel. A common problem for New Zealand universities. We're stuck at the edge of the world. I mean, I love it. I'm glad that we're here, actually. But we do tend to need, there's I'm going to say a need to travel, but there might be a question mark over that. And then we've got through electricity and some of the other smaller sources as well. So that's our carbon profile. And that's basically a roadmap, isn't it, for what we need to do and attend to in order to achieve that carbon net neutrality. This chart here is just giving a sense of of what's been happening with coal. So we had this quite nice drop after we started with CMARS, which kind of looks awesome, but it was actually the earthquakes shutting down the campus so that we weren't heating our buildings. I shouldn't laugh. And then, but what's nice, so this red line is if we had done nothing after that with our built environment, what would our carbon emissions from coal look like? This is the kind of the real through to now, and that's been achieved by building our new buildings better, and also refitting a lot of the old buildings as we progressively go through. And there was an initial wave of repair, and there's still ongoing work. So when we can, we just improve the thermal efficiency of our buildings. But you'll see, I think, when you go and have a look at the storm water garden that Tom will take some of you on. That's coming off the Ernest Rutherford building. These new buildings are really good. They're very efficient. But we've made some other gains around getting off coal. So our new Students Association building, the Haereroa building, is heated through ground source heat pumps. So it's not attached to the coal system at all. Ernest Rutherford has some ground source heat pump capability. It's going to be transferred entirely over to ground source heat pump in the next couple of years, we hope. Yeah, and then, but of course this is the main bit of this chart, which is where we drop off coal completely and switch to wood chip, which is meant to be happening this year, but I think we're going to, because of COVID, see that just stretch out that way just a tad. Yeah, so that's going to be nice, and just with that change, see that massive drop in carbon emissions. This is another chart basically showing the same thing, but making an assumption, the same assumption. This air travel line will be a lot less this year than what was projected in this chart, so more like this, because we're not travelling anywhere. It could be even less. We don't know about 2022. it's still showing that massive drop in the boiler plant emissions from 2023. But there's something quite important in here too, which is predicting a 5% per annum decrease in air travel, something that is stated in our carbon emissions plan, but needs a wide conversation within the UC community to figure out how, in fact, we would possibly enforce that or encourage that, how we will achieve a 5% reduction in air travel. So that was the carbon in a nutshell. There's also another thing that goes along with this, which is the carbon sequestration program. Which we're just figuring out at the moment, how much carbon could we sequester off our own land, our own forest estate? And will that, to what extent will that help us achieve neutrality somewhere in here? Sort of predicted that it's possible, but we're going to have to buy offsets like everyone, so it's a bit of a pickle. Just the last thing is coming back. You remember the 5 bits of the sustainability strategy, and the last one is about partnerships. So UC is running the Sustainable Development Goals Summit series, starting last year and finishing this year. It's part of a 10-year series of events that's meant to bring together the business, the community, academic, government sectors to figure out how we're going to meet the Sustainable Development Goals as a nation. And so it's an invitation, really. It's an invitation to any of you, if you would like to participate, certainly if you want to come along, you're very welcome. There are 3 online hui. The first one we've actually already had, but there's 2 more coming. Next one is 25th of March. And then the face-to-face summit, which is going to be here at UC in September. So that's basically the progression through for that. And we'd love for you to come along and and share your stories and participate. So I think that's the end. If you've got Facebook, you might want to like the Facebook page, Aotearoa New Zealand Sustainable Development Goals Summit Series. Or find us on Instagram. So that's me. Thank you again for your time.
Awesome. Thank you, Matt. So if anyone's got any questions for him, you'll be hanging around afterwards. So, yeah, awesome, cool. Perfect. So next up, we've got Leon Erasmuson. He's from Callaghan Innovation and will be talking to us about student grants.
Among other things. It's listed here, the name says it all, it's New Zealand's Innovation Agency, and we're a government agency. A large slab of what we do is funding. Last year, nearly $500 million. A large chunk of it in the last 6 months with R&D loan schemes, so these are very low interest loans to industry. For those whose operations were basically bunged into hibernation because of COVID. Really good. There was some fantastically interested stuff in there. Really interesting listening to the presentations with Daniel, who's not here, I see. Really hard not to love mechanical engineers, got to say. A large portion of what we do is the grants, but that's just a chunk. Innovation skills, there's lean for industry, capital education, because what we're looking at is the stuff that you do from R&D has to be commercialised. And to do that well, you need to do it efficiently. On top of that, Callaghan has 200, 250 scientists and engineers. So there's a massive R&D resource in some fairly specialised areas. Advanced materials, data IoT, it covers a very wide field. And then the one that I particularly think is really important is the connection services that we can do. But student grants, we're in a university. The purpose of it is to draw students into industry and to get industry to do more. It helps companies, I suppose in its crudest level, work with students. We pay for it so that you can do stuff that would otherwise be sitting in the background doing nothing. When I was in industry, I shamelessly got into this like there was no tomorrow, and I'd encourage companies to do the same. If you're doing R&D, student experience grants over summer, 400 hours, 10 weeks, Callaghan pays for it. We're not wanting you to spend weeks doing an application. This is very quick, very online. Make use of it. It helps the student. It gets them into industry, gets them experience, and gets them excited. It's pretty important. We just covered that. Basically, it's 400 hours, 10 weeks, is a reasonable amount of money. And frankly, at its bottom line, it beats the hell out of students standing on the side of the road with stop-go signs pretending it's part of their, their degree practical. Masters, PhDs, these are the fellowship grants. These are really good. $26,000 a year, tax-free, stipends, plus the university host fee. It doesn't cover fees, university fees. Sometimes companies do cover it, but that's something that we don't get involved in. There is no application period. You can do this, you can start this anytime in industry. You do it when you've got a really knotty problem. You need to spend a year to 3 years, depending on whether it's master's or PhD. It is massive value for money. And it gets students into industry and working. And then there's the career grants. So if you look at the flow of what's happening, you start with the experience grants, you roll into the masters and PhDs, and then when they're finished, you're looking at the first 6 months of their first job in industry. Callaghan will pick up the tab, and it's $30,000 to $35,000 for the first year's salary. It's to ease the flow into industry for students. That's the purpose of it, and it works really well. I suppose you really need to be talking to Callaghan. Tell us from industry point of view what you're trying to do, and we will basically bust ourselves to figure out how do we do this. Some of it is the running of the flow of students through, connecting you with other government agencies, and on the plus side, whilst the application processes have been a little bit onerous in the past with, say, project grants, change is afoot. It's not there yet, but change is afoot. And we can help in other areas. So, quick recap, experience grants, which are really summer interns, fellowships, then flowing into career grants. And overlaying that whole thing is project grant applications. Callaghan would pick up 40% for approved projects. It's 40% of your project cost. That's not to be sneezed at. It's pretty good. and I'd encourage you, get onto the website, have a look at it, ring us directly. You know. That would be about it, if there's any questions. It's a pitch. And people shouldn't be allowed out of here unless they do this.
Any questions for Leon?
Yeah, which part of industries are typically tapping into, you know, all the options you got there as students?
It was interesting. I was wondering how much of that would resonate. And apart from the fact that, yeah, I am an optimist and I'd try like hell to be in that top end, but it's hard. I can think, without dumping companies into the deep end, I can think of probably half a dozen projects just off the top of my head from the last 6 months that would relate directly to the sustainability field. And I was looking at extracting value from waste, the stormwater side of it, and thinking you can see small projects who are companies doing small amount of things. The hard bit is linking them all together. And I think somebody's vaguely apologised for saying didn't want to bang on about sustainability, and I disagree. I think we should. In fact, a lot. So yeah, there are a hell of a lot of projects out there. If you've got ideas and you want to be linked into networks of companies who are working in a similar field, that's something that we can do. It's not hard, just call us.
Yeah, because it sounds great what you're saying, because you're rearing to get in behind and help, because that's what you're there for. So it sounds...
Yeah, and really you should be doing it. If you're not taking advantage of this, there's a degree of negligence. Really, I'm not joking.
For a finite resource?
Pardon?
So you're competing for a finite resource each year? Is there a funding round?
It is finite. There's not an infinite pot of money. But, and say for the student grants over some of the internships, there's usually a limited number. And it is a first in, first served.
And it gets exhausted.
And it does get exhausted before the end of the year.
Yeah.
But really the early bird does get the worm, you know.
Where are we at in that cycle at the moment?
It'll crank into action again around May for those interns at the end of the year. But the criteria aren't onerous, they aren't huge. Projects is a little tougher, but it's doable. And for a 40% funding, there's a big carrot there. To wade your way through the bureaucracy of part. I can say that because I'm retiring soon. So you should be doing it. If you really aren't, it's negligence.
Awesome. Cool.
Next.
Thank you. Perfect. Awesome. So next up we have got Jonathan Pooch, who is Managing Director for Data Consulting and also an Adjunct Fellow of Chemical and Process Engineering.
Awesome. Cool. Thank you. Yeah, so look, I'm, as introduced, Managing Director of DETA Consulting. So we've got a relatively small team of 25 odd people, engineers, project managers, running around Australia and New Zealand trying to reduce fossil fuel consumption in large industrial processes predominantly. So what I was going to talk about a little bit today is we've been quite deep on technical. That's not going to be me for most of this. But I thought we've got to frame up the problem from a New Zealand perspective. So specifically looking at carbon, and I know that's only a subset of sustainability, but that's a subset that gets me up in the morning. So what am I talking about? It's that industrial process. So that is those carbon emitters that directly come from industrial processes, steel manufacture, refrigerant loss, aluminium, cement. We all, you know, the big plants around New Zealand, but equally looking on the energy side It's this manufacturing piece. So 2.9% of New Zealand's carbon emissions come from dairy processing. That isn't on-farm, that's captured separately, that isn't the animals, that's captured in agriculture, that is purely converting milk into milk powder. And that is what we are doing lots of every day. Okay, so really we've kind of gone through this evolution. I mean, DETA's been around for 10 years. When we first started, we were having conversations all the time around, man, we spend a lot on energy, we should really do something about that. That was 10 years ago. And since then the price has only gone up. But that was all our entire conversation. From a strategic perspective, there was next to none. We started to move on, say mid-2010s, to phase 3, which is really where most of what we are sitting at now, which is this is really, really important. That's why we've got events like this. We must do a lot better. And at that point, for the first time, we're actually starting from a DETA perspective, actually having conversations at a more strategic board, senior manager level, rather than an engineering operations type level. But there's still a step to go, which very few, if any, New Zealand companies have actually got to, which actually true sustainability and true health and safety and all those sorts of things, if we've really nailed it, we actually don't need a sustainability manager or a health and safety manager, because this is just how we do things around here. This is just us. And we talk about some of these things around, buying local, and we had some of that conversation early on. Well, if that's just what we did, some of this would just be how we behave. We don't have an ethics team, for example, because that's just how we operate around here, right? So that's the aspiration in my mind. How can we get to this point? Now, what we are seeing is a real commitment from large business. I mean, we're dealing with Fonterra's, Synlays, Westland Milk, Silverfern Farms, all of these sorts of organisations now for the first time converting conversation to actual real strategy and real senior board alignment. And a lot of that is, yes, we need to be ambitious with what we're talking about. Alliance said the other day that they're going to exit coal by 2030. Synlay have been quite vocal in a 50% reduction in all of their carbon emissions on farm and off farm. There's lots of these statements. The challenge is sometimes how do we actually go out there and do that? So the rubber on the road is actually now really important, and that step-by-step process. So for us, and how we have the conversation with organisations we're working with, broadly speaking, it's a 3-step type conversation. Firstly, we've got to look at the process. That actually raises quite a few challenging conversations for a Fonterra. Drying milk is really energy intensive. Are we going to be doing that in 2050? It's a pretty hard conversation to have when you're just sort of starting down a sustainability journey, but it's really hard to have a sustainability journey without addressing the elephant in the room. For our meat processing plants, what's the impact of our plant-based meats? Do you have a role or do you not? And what does it mean if it has a bigger role than you think it does? So this is really important to anchor sustainability strategy with business strategy. And that's where we've taken some great steps recently. But equally, there's lots of other ways to do what we do now. We don't have to dry milk. We could do UHT. We could export clean, green New Zealand water, and it would last almost as long and deliver into market almost as well. So why don't we do it? So I think the ability to stand back and look at the process is an absolutely critical part of actually what we need to do. So we need to get the benchmark down before we start tackling the energy usage. And Daniel hit the nail on the head. Some of the stuff is down in the trenches. It is not interesting. I find it interesting, and our team finds it interesting, but some of it is just hard graft, right? But a lot of the demand side stuff, this is a live example from a design review we did for one of our more enlightened clients in November last year, where they were about to spend 30 mil on a brand new plant that was going to still be around in 2050, and they were cutting corners, and the design spec was not considering sustainability at all, and a simple review said 70% reduction in peak heating loads and all these other benefits, and the net capital cost increase was 0.5% of the total build. It's not rocket science, right? We have to get this right early on. And the challenge that we are having with clients at the moment, and again, I'm not always so popular, is if you're building a new plant today, is it still going to be around in 2050? And if the answer to that is yes, then shouldn't it be net zero today? It's not always so easy to have that conversation. But equally, we've got to get the basics right. You know, we walk around plants and you can't even have a conversation because you can't hear yourself over the compressed air leaks. It's the least efficient utility there is. System improvements, heat recovery, all of these things are the basics. Down in the trenches, do the hard work. You know, 10, 20% even in a large consuming site, you can definitely do that. And there's numerous examples of that being real across the board, not just an industrial process. But at some point, we have to tackle the elephant in the room. We'll do all of the best work we possibly can. We'll educate our staff, make sure they don't run that hot water hose down the drain and all of that sort of stuff. But at some point, we have to tackle the energy source conversation. So process heat at the moment is dominated by coal in the South Island and natural gas in the North Island. We have to do something. High temperature heat pumps are economic today. Anything less than 85 degrees, we can electrify that at high efficiency, you know, coefficient of performance up to sort of 4, possibly even 5, and it beats coal today. So why aren't we doing it? Biomass, electrode, waste to energy, geothermal, all these sorts of things have a role in the right location. They're not all perfect for every single site, but they do have a role. And it doesn't take much of a change in the carbon cost to have a pretty significant impact on the fuel selection and the economics, but equally, we're currently sitting at around just a shade over $30 a tonne. Coal is still looking pretty good compared to the alternatives. So we do still need some work from a system perspective that at the end of the day, these businesses still do, rightly or wrongly, they still have to find that sweet spot in the 3-ring circle around what sustainability means, and they still have a business to run. And at the moment, for many, coal still has a role to play, unfortunately. So just a couple of really quick points on renewable energy, because we're doing some cool stuff on renewables at the moment. Geothermal, everyone knows, Kauro, Taupo, you know, all of those sorts of areas. Geothermal, lots of interesting examples. Miraka is a milk processing company that is entirely off geothermal, but actually there's some really interesting other zones of New Zealand that could be an option, and I know Western Milk and GNS are currently doing some research looking at some geothermal in the Alpine Fault Band, which is really interesting from an engineering perspective, and there's some really interesting early stage results on how that might be an opportunity in a more broad sense from NZ Inc.'s perspective. Equally, the biomass. Now, there's some mixed views around biomass longer term, but as at worst, a transition fuel to get away from coal. You know, there's lots of opportunities, and there's actually quite a high correlation between areas of weakness in the New Zealand electricity grid and areas of high biomass potential. So if you look at areas like the East Coast of the North Island, Hawke's Bay, Nelson, Marlborough, they are poorly serviced by electricity generally, particularly if we were going to go, okay, here's an 80 megawatt boiler that we want to put on into electricity, if that's the alternative. But they're quite well serviced by biomass. So there needs to be a little bit more system thinking. But retrofits are really difficult without going into the detail. Biomass is low energy density, high volume per unit of energy, which makes it really hard to just drop in and retrofit. So often, high capital requirement, you know, brand new boiler sort of scenario most of the time. Electricity, we talked about high temperature heat pumps, electro boilers. So Synlait have a 6 megawatt electro boiler down the road. We've actually got a client of ours who has electro boilers since the 80s, when electricity used to cost 2 cents a kilowatt hour. They have that as sunk investment and can't run it at the moment because it is too expensive to run. So the alternative for them, it costs them $1 million a year to run versus the base alternative. So this economic argument is still a challenge and it's still a constraint and it's still an issue for us. Equally, we have some issues, 80 megawatts, let's say, at Edendale. That's roughly a third of the size of the Clyde Dam, and we have to be able to get the power there. So some of those electrification issues are going to go beyond, and you know, we're coming mainly from a client side. It's pretty hard for the client to help support the wider scale planning when Edendale's just one plant of maybe 8 of that size and scale in the South Island. So how do we get the better planning from an NZ Inc perspective to allow the clients to work in a collaborative way to make the right decisions holistically rather than just looking at their own individual option? It's really difficult. I am going to make a comment about hydrogen. I was going to... look, for the majority, hydrogen's going to have specific use cases in my view, but ultimately you're getting it from renewable electricity, and if we've got renewable electricity, then shouldn't we use the electricity already, particularly given the conversion efficiency of hydrogen is currently not so great. Solar certainly has some interest, but we're getting into those areas of R&D, which from, or commercialisation, I guess more than R&D, that lots of end-use customers aren't yet ready for. You know, they're not yet ready to take significant risk in that regard. So just to wrap up, what does all this mean? Look, 60 to 80% reduction, and we've done it across the board, across sectors. That can be done today with current known technology. We could do that tomorrow, right? The issue in most sectors, and it pains me to say because I'm an engineer at heart as well, but it's really not for most organisations to get those 60 to 80% improvement. It is not a technical engineering challenge, it's an economic challenge. And as soon as we get our head around the economic challenge and the underpricing of environment, resources, sustainability versus the subsidisation of other elements of the economy as well, versus us as consumers being comfortable actually for paying a little bit of a premium for some of the products, then we can actually create something that can find that sweet spot between social, economy and sustainability. And just that final point, because I see it all the time and it gets me in trouble all the time when I'm talking to customers, is if we are building a new project now, is it going to be around in 30 years' time? Because I'm dealing with boilers that were, you know, 1931 is the earliest nameplate on a boiler that I have been to in the last 12 months. It's awesome with my engineering hat on, but I can tell you it does burn coal. You know, some of this kit will be around in 2050, and therefore, in that context, we need to think differently and be far more aspirational. Now, people are getting there, but the rate of change, it's a big ship to turn, and I think it's up to us, government, and the consumers themselves to really make the boat turn a little bit quicker. That's me.
Any questions?
Shoot.
You mentioned one example where the economics was like a $1 million percentage increase.
Yep.
So, and you're talking about 2050, so over a lifetime, isn't there a good economic case as well?
Yep. So, look, it's an absolute slam dunk. If you look at any sort of MPV, in fact, we could have done just simple payback and it would have been months rather than years. The challenge, and we still get caught, almost all businesses, in not adequately looking through our procurement process and design process and getting so focused on CapEx rather than OpEx and not striking the right balance. Now, I'm not saying that CapEx is, we've got to completely ignore it, but it's finding that harmony and assessing things in a way that allows design consultancies, the actual equipment providers and the consumer, the end user itself, actually to innovate a little bit, because I'm not entirely convinced some of the time that our current procurement method actually allows us to do that, because it's just lowest cost CapEx and then we fight hammer and nail to the end of the project, often.
Yeah, I was just wondering about that payback time. Are you seeing any changes in how people are approaching it? Like if their plants are going to be there in 2050, are people still expecting ridiculous 1-year payback times, or are they thinking a little bit beyond?
People who engage us maybe are slightly more enlightened, so they accept slightly longer paybacks. I think there's still a lot of pressure on capital return, and the acceptable paybacks are still shorter than I think they should be. There is some uplift though, I think some general awareness. I think what is really changing is not so much, say, the pure economics. I think it's changing in the industry's ability to develop a better story. So, I mean, Daniel, and quite rightly, he sort of said, well, you know, often it's about the story. And at the end of the day, the business case is a story, right? So yes, you need to tell the financial argument, but how does it fit in with strategy, et cetera, et cetera. And I think it's easy to just dismiss financials and that's it. And we talk about it in our team quite a bit. If we're just putting an energy project up based on savings, then we've missed the boat, right? Because every single project, even a relatively simple LED lighting in here, it's about maintenance that we talked about. It's that longer life. It's about occupant environment and comfort. And all of those things, and some you can monetize and some you can't, but it's how do you stack it up? So I think we're seeing a little bit of growth in terms of acceptable financial payback and criteria, but we're seeing more growth, I think, in that acceptance of the non-financial, even some of the customer acceptance, social license to operate. You can then put that into your business case, and that all of a sudden then gets you a little bit more mileage than you otherwise might have previously. Still more room for movement on financial criteria in a 2050 environment, but some flex.
I feel like the biggest problem there is that while the factory might be there in 2050, the CEO isn't going to be there.
Yep.
How do you get around that?
It's difficult, and then we could go down the rabbit hole of 3-year election cycles and all sorts of things on that for a similar sort of argument. But fundamentally, I think you're right, and that's ownership structure. I think there's a whole host of things that we're seeing. I haven't really done a survey of our clients, but you know, those with more long-term ownership structure aspirations or community-led aspirations have, you know, Māori organisations like Miraka, really different investment profile to straight short-term. And I mean, if I could solve that, that would be awesome. But you're bang on.
So would that mean that the decision-making and the investment is more willingly engaged in, say, with Maori companies and with larger private companies where they can just simply make a decision regardless?
Yeah, I think certainly, I mean, we don't have heaps of examples probably on the Māori company side of things, but certainly from what we're seeing, that their visioning is far longer term, far more committed than many others. I think publicly listed is always really difficult from our experience to date. Actually, some of the multinational investment is actually far more positive in terms of that longer term visioning than perhaps what might be generally expected. You know, with some of the Japanese, Chinese, Asian-based investments, they are really thinking long term because that's why they've invested in NZ Inc. So, you know, there is some interesting stuff coming out of there at some of those organisations as well in terms of strategy, commitment to, and alignment with sustainability. Sweet. All right. Thank you.
Thank you. Cool. So next up we've got Simon Love, who's Environmental Assurance Lead at Asure Quality.
All right, thanks all. Just out of curiosity, can I see a show of hands who's heard of Asure Quality? Oh, that's good. lots of hands went up. That's good. So my name's Simon Love, and I'm the Environmental Assurance Lead at Assure Quality, which is a new role as of November last year, to really focus on making progress mostly in the environmental space, but thinking about the other sustainability aspects as well. In terms of what Assure Quality does, for those of you that don't know, basically if you've eaten anything that's been produced in New Zealand, probably Assure Quality has been involved somewhere there. So there's lots of on-farm inspection services for environment, for industry assurance programs, for disease management, biosecurity, all those sorts of things. There's lots of food safety work. There's environmental management systems and food production, all the way through anything that needs doing in that sort of area. And it's quite a large organisation, so 2,000 people around New Zealand, and it's also owned by the government, which gives us kind of, in my view, a bit of a mandate to really push to be the best on the sustainability side there. What I would like to do is just run through kind of a sample of environmental issues that are happening in the primary sector right now. So really looking at kind of on-farm area, and just kind of, I guess, start thinking and having a discussion and opening it up for questions after that. So the kind of things that I'm looking at when I talk about the key environmental and sustainability issues in the primary industries. So environmental ones we know about. Carbon, obviously, on Jonathan's pie chart there, where everyone's thinking about the methane emissions and the emissions from the primary sector there. There's a lot of water issues. People tend to think about dairy on that side, which you're all very familiar with, and then biodiversity and soil ecology issues on farm. And then you've got some really interesting parts that play into the sustainability kind of spectrum there. So you've got farmer well-being, which I guess has also been in the media a bit, sort of the stresses of complying with all these different things and making a living off the land. You have issues of rural identity. A good example of that one is, if we think about transferring everything from farming to forestry, for example, what happens to our rural towns? There's far fewer people needed in forestry, for example, than in farming. And there's Te Ao Māori, the worldview there, and lots of really interesting conversations happening about that at the moment. Then you've got sort of governance and economic issues there. So governance, people are very concerned about transparency, where your food is coming from and what happens to it, and that includes all those other aspects like animal welfare. And then on the economic side, some of the primary sector parts are relatively low margin, and that can create a barrier for sustainability issues as well. You kind of stole my thunder a little bit here in terms of difficult topics and hard truths. So these questions are very tough to answer. Lots of these conversations come up when you think about sustainability in this area. So when we think about, for example, are we using our land in the best possible way? Well, what does that mean? The example I gave of if we converted all the dairy farms that used to be forest back into forest, what happens to the economy? What happens to rural towns? What happens to people's livelihoods? And there's all kinds of land use changes that would have pretty significant impacts on other areas if we looked only at environmental sustainability. Can we keep doing what we're doing and stay within environmental limits? That's kind of broken up by area within New Zealand, but there may be parts of New Zealand where the current types of farming that are happening there, no matter how much you improve them, are just not sustainable to be there. And that's another very tough conversation to have. And then, should we be eating less of certain foods? So we're looking at alternative proteins and alternative milks and nut milks and things like that. There's lots of conversations to be had around there. Are the alternatives actually better for the environment is one. Obviously, alternative meat doesn't involve killing an animal, so from an animal welfare perspective, it's a win, but then there's different issues all over the place, and we have to kind of balance those. So I wanted to just pick some examples of some quite cool work in progress happening in this area. Let's see if my animated GIF works. It does, that's great. This is a piece of research that came out recently through one of the one of the National Science Challenges called Our Land and Water. And if you look at the map when it's mostly red, that is mapped out where there is nitrogen excess in waterways. Darker the red, the more nitrogen excess in waterways there is. And then the other map is overlaid is how much that could potentially be reduced if all of the kind of tools in the current toolkit of minimising nitrogen from farms are implemented. So riparian planting and fencing waterways and all kinds of things like that. And what this really shows that there are some areas, like lots of parts of the Canterbury Plains, where this would make a really big difference and it's definite win. And then there are some other areas on that more blue map where it's light coloured, kind of green towards yellow, where even if all those things were done, we would still have the problem of nitrates getting into waterways. And so then you start raising the question of land use, like I just talked about. So that's it's really cool to see some research happening like that to open up those discussions. Another really, I think, great piece of work is Fonterra. What they're doing is providing environmental scorecards to all of their farmers. So these are customised documents that they give out, and it really breaks down how they're doing in each of the different areas of their farming practices. It benchmarks them to other farmers in the region and in the country, and kind of sets them on a path to doing well there. So, and uses a really nice layout, traffic light system. Cool piece of work. Another piece of work that's happening right now is on the carbon side. So there's a sector-wide strategy called He Waka Eke Noa. Very ambitious targets. So by the end of next year, all farmers in New Zealand should know their carbon footprint of their farm. By end of 2024, they should have an emissions management plan, and by end of 2025, there should be basically a system accounting for all of those greenhouse gas emissions, and also with a pricing mechanism in place. So that's nice to see, basically a sector-wide push, strong push then. We'll see if it's physically possible, because there's 40-odd thousand farms in New Zealand, but I'm relatively optimistic. I think there's a definite knowledge that there is a need for this to happen. Another really interesting one is a trend towards regenerative agriculture, and if you're wondering what that is, so is everyone else. So that's why MPI has got a request for proposals out now to really understand what regenerative agriculture is in a New Zealand context. And what practices would come under that umbrella were we to formalise that and, for example, have a system where you could get a stamp saying, I'm using regenerative agriculture practices. So that's a bit of a mystery. It's a little bit controversial at the moment in terms of no one really knows exactly how well these practices work, but it's a really interesting area of research. And for my last little bit, just some notes on some interesting trends in the sustainability in the primary sector. One is integrated farm planning. I'm going to put up this huge diagram. I'm not going to go through them, but as more and more requirements are being put upon farms, so that you've got the carbon side, you've got the water side, and then you've got all things some things are already done, like animal welfare, and then going out to the more sort of fuzzy things, like some of the governance aspects, for example. What we don't want is to have a plan for every single box on that diagram that is helped along by a different person, is audited by a different auditor. It could just be the farmer could spend their whole year filling out paperwork. So the goal is eventually to have an integrated farm plan where there's templates, there's assistance available, and all of this information can be kind of put in one place. And a key part of that is digitising that. So obviously there's a lot of data in an integrated farm plan like this, and how could we use that data for the betterment of New Zealand or the world rather than just the betterment of individual farms or companies. Keeping on the data and digital side of things, there is a lot going on that side. There are good software programs out there to help with farm management and nutrient budgets and tracking all those inputs and outputs. So we're seeing a move towards that and really a lot of technology going in there in terms of mapping and digitisation. And one other trend, I'd be remiss to not talk about this, seeing as Asure Quality does some of this, is assurance marks. So if you tell someone that your farm is sustainable, well, how do you believe that? So there are programs out there to get sort of third-party audited on that. So these ones here, we've got good agricultural practice for the horticulture industry. We've got farm assurance program for the red meat industry. You've got labels like grass-fed and animal welfare. And then one program we're rolling out now is a partnership with us and Overseer and Toitu, is the farm carbon certification. So that's using ISO 14064, which is the corporate organisational carbon footprint that's been modified to fit for farms. So it's really robust and transparent, and that's recognised worldwide. So we're kind of seeing this demand for real assurance on that side. And I've gone a minute and a half over, but that's it. Thank you.
Any questions? There we go.
Who's paying for this? Is the government paying Asure Quality to do
The farm plans? The farmers will pay for the farm plans, so farmers will engage, the government will set the framework, farmers will generally hire a consultant because it's difficult to do alone to get that farm plan done, and that planner usually has qualifications and a lot of experience on that nutrient budgeting and water side, and then Asure Quality does the audit to make sure that it's up to scratch. It is, yeah. It has created those costs, but I guess that's seen as still the most effective way to roll it out. Oh, sorry, come next.
Sorry, Leon.
No, I'll
Yeah,
go
I've
with you.
just completed a project for our land and water, and looking at the gap between what policy writers are creating, and the uptake by farmers. And I could be here all day telling you what the results are. So the problem is psychological, often.
Yeah.
And the psychology is altered, is impacted from the reality of day-to-day farm and finance. And if you're in debt, this part of your brain is occupied, and you cannot concentrate on new technology. So I would assert that a technology solution is actually not going to help much for the majority of farmers. When you get corporate farms, yes, because they're a specialist. When you get the average farmer, they come in from a day on the farm, they're exhausted and they're worrying about the future of their existence on the farm. It's an enormous problem. And so these experts that go out there need also to be experts in psychology. Where are you going to get that mixture from?
Yeah, there's going to be a shortage of experts across the board over the next 5 years, for sure. Yeah. Thanks.
The holes in the map, where do lifestyle blocks fit in, if at all,
On the nitrogen map?
on any of it? Because some of them are classified as farms.
So the farm environment plans that are going to be regulated that have to come in, there's a minimum farm size of 20 hectares or 5 hectares for hort. But yes, if a lifestyle block is bigger than that, then they're still going to have to do a farm environment plan.
So why aren't, to some degree, filtering smaller?
What's
The requirements, you talked about by 2022, your carbon footprint needs to be known. There's some sense in that.
Yeah, well, so the carbon footprint, the He Waka Ekino, is separate from the farm plan, so that doesn't have the same guidelines on the farm limit. I mean, it'll probably be used as a rule of thumb, but yeah, you're right. All farms should know it. Yeah.
By doing this, does the farmer if the farmer does all the paperwork and if all the paperwork is correct, does it improve the efficiency of farm in any way?
It should do. There are plenty of farms out there who don't even have a digital map of their farm at this point. So it will bring up the whole industry.
Okay, so it's not just a feel-good thing that we'll have some paperwork.
It's definitely not a feel-good thing. No, the immediate focus for those farm plans is on the water side, and my understanding is that there'll be a lot more government research work on monitoring and be able to see that it is making a difference. Yep. Combined with things like fertiliser caps and stock exclusion and all kinds of things. Yep.
There's a lot of pressure by the people selling the fertiliser, isn't there? The companies who are selling fertiliser put pressure on the farmer to keep using the fertiliser that it's selling.
To some extent there is, and a lot of the advisors are hired by the fertiliser companies. So, yeah, there's lots of issues to discuss in there. Yeah.
Well, changing systems and they can reduce production.
They may have to.
Doesn't necessarily reduce profit, though, when you do that. It could be better.
Reducing production is not, and having more land is what the banks want them to do. No, the banks want them to increase stock and increase land holdings.
Yeah.
They'll support that, but we're telling them to reduce land holdings and reduce stock and look at value over production. So there's two really
Correct.
big themes here.
And I would say us as Assure Quality are in the middle of that,
Yeah.
helping to just kind of facilitate that discussion. But yes, there's a gap between the government, the banks, the farmers, and all the parties, and so that's just one of those hard truths that we're just going to have to face. Yeah, I'm sure I've used up my time. So.
Sorry. I'm sure he'll be around afterwards to continue any conversations. Awesome. So next up we've got Rae Stewart from BECA, who will be talking to us about design, sustainability and design.
Thank you. Hi, my name's Rae. I did chemical engineering here. I was trying to work it out. It's somewhere between 20 and 30 years ago, so it looks quite different and it's quite strange to be back here now. But really good to hear there's been a common theme that's gone through a lot of the industry presentations, and so you'll hear a bit of repetition from me from what Jonathan said and also what Matt has said as well. So what I want to talk to you a bit about today is a case study of a project that I've been lucky enough to work on with Queenstown Lakes District Council, which was the upgrade of their wastewater treatment plant in Queenstown. So Queenstown is beautiful. Everyone wants to live there. It's growing massively. They did upgrade their wastewater treatment plant in 2014-15, and that was supposed to last a long time. I think somebody's graph said our expectations and what actually happens are not quite the same. And now in 2019, they realised that they needed a second expansion to match the growth in the area. So from a sustainability point of view, we know we have to build a new treatment plant. What realistically can we do as engineers as part of our design to bring sustainability into that project? And one of the key things here is about how we can help our clients understand what they can do to meet their climate targets, because QLDC had introduced a climate action plan, but I think as we've talked about a lot before, it's very easy to talk about it and say, yeah, it's great, we need to do something, but it's much more difficult to understand exactly what it is that you can do to make a difference. So I think it's one of the most scenic wastewater treatment plants in the world, and a bit of a pitch for wastewater treatment, growing business, you'll never be out of work. So here you can see there's an existing clarifier and reactor. Apologies for my technical terminology, but a biological reactor to treat the wastewater clarifier, and then some oxidation ponds before the treated effluent is then disposed to land. So what this project involves is a second big concrete reactor, a second big concrete clarifier, but actually decommissioning the ponds. bit of a timeline of our project. So we were really lucky that QLDC put in their request for proposal, we want you to consider sustainability. So that's, you know, we get excited about that sort of thing. Often economics prevents us from doing cool stuff like that, but they were saying we want you to do that. So we had a kick-off meeting and we just talked through and brainstormed a whole lot of ideas, and we came up with initiatives registered that I'll talk about soon. And then we worked through what was actually feasible to implement on the project, and it's both from an economic point of view and an acceptable point of view. We're currently just finished preliminary design, so we've still got some stuff to do, which is great. So yeah, the sustainability, a lot of it's in the messaging. There's a lot of technical terms out there, and how could we convey to our client what the impact was going to be of some of these changes. So here's just a snip from our register. We're talking about blowers. They're going to cost a bit more up for the capital cost, but your operational cost is going to be a lot less, and your operational carbon is going to be a lot less, so your emissions over the lifetime. And we just went through, and I think maybe we had 10 pages of these different ideas that could be implemented on the project. So yeah, we've talked about, a few people have referred to carbon. We've talked about carbon a lot. Why do we use it? It can be quantified. It's easy to talk about. People understand it. And we can compare apples with apples when we give them all tons of carbon equivalent. So from our point of view, we looked at the project from two aspects: capital carbon and operational carbon. And very similar to what you were saying before, we found that capital carbon overall is probably only about 10% of the carbon impact for a project. The rest of it comes from the operational decisions that are made. So capital carbon looks at the whole life cycle of the project, and you talked about, is the site going to be around in 50 years or whatever, or what happens to it when it's not and it has to be demolished? How do we get the materials to site? What do we build with? And operational carbon, this is where I'm going to show my ignorance a bit, because I'm lucky enough to have some really fresh graduates that work with me and are very up on this sort of terminology, but made up of 3 different types of emissions when we consider operational carbon: direct emissions, indirect emissions, and then scope 3 ones, the ones that are indirect but not from the previous group. So what did we produce for the council? Well, we looked at cost and carbon NPV assessments. So rather than just assessing an option from a cost point of view with an NPV, we looked at what is the whole of life carbon impact for that option. And then we gave those paybacks. And you can see that some of the more efficient carbon options that we're presenting are actually lower cost as well. So one of the learnings from this project for us, that in a lot of cases lower cost equals lower carbon, and vice versa. A lower carbon option does equal lower cost. There were some things that we looked at and we just had to admit that although it was a great idea, it just wasn't going to pay itself back and it wasn't going to work financially. So here's a picture that we tried to use to convey what we'd done. For our project, we did a capital carbon baseline and operational carbon baseline of the project before we had implemented any initiatives. And this here is the greeny yellow one is the baseline. And then the 4 things in the middle are the initiatives we're implementing over the project, and then the estimated footprint after we've implemented those reductions. So things that we've talked about there: reuse of materials on site rather than taking biosolids off site, using it for landscaping bunds, investigating low carbon concrete, because concrete is 70% of the capital carbon for this project, efficient design, and then looking at efficient process equipment. And operational carbon baseline. So As I referred to before, you know, your operational carbon goes on for the life of the project, and you can see emissions just keep going up and up and up as the life of the project proceeds. And that was our baseline. And here we tried to capture what we have achieved, so QLDC can show that they're working towards their climate action plan by the different opportunities for carbon reduction across the project. And as I keep saying, capital is only a small part and only in that first year, and then the operational is the key thing to consider going forward. So for this particular project, when we decommission the ponds, we've got a decrease in tonnes of carbon, but we have more biosolids coming from the new reactor and more more nitrous oxygen emissions from the treatment process as well. So just a bit of a summary of where we're at. So we've agreed to implement energy efficient blowers. We've looked at different types of concrete and using fly ash in our concrete to reduce carbon content. We've looked at material options for a lot of the main process items we're specifying. And as we're going into construction, there's a lot more options we've identified that we are going to continue to pursue. Biosolids is a big one for this project, and making sure we can try and keep that on site and reuse it as much as possible. And another piece of work we've also been doing is sort of an energy assessment district-wide, looking at whether we can have a central energy unit that would take some of the biosolids from this project and use it to heat swimming pools and things like that. So the great thing about this, it's been a really learning experience for both the council and ourselves, and we've been able to roll out some of these philosophies to other clients, and also we're now looking at the Wanaka wastewater treatment plant expansion. So things we've learned is to, I guess, not, despite what Daniel said, not focus on the small stuff and spend hours and hours analysing how much carbon we can save from a small thing, but instead to focus on big picture concrete, efficient blowers, motors going forward, reusing waste materials where we can, if at all possible. And so, yep, I think it's an exciting field to be in and lots of opportunities. And yeah, as been mentioned before, at the moment, the story, the messaging, and how you convince people that what we're doing is going to help them meet their climate action targets is really important. So I have no idea how long I spoke for then, but thank you.
Do we have any questions for Rae? Okay, cool. Great. Thank you. Awesome. She'll be around afterwards if you want to ask her any other questions. Just give me questions. Awesome. So, we've now got our final speaker, who's travelled all the way up from Timaru to have a chat with us tonight. We've got Nigel Davenport.
Excellent. After you. Last cab off the rank. I need a drink, so I'll be quick. Yeah, look, my name, Nigel Davenport. I'm the CEO of Venture Timaru, which is the economic development and tourism agency down in the Timaru district. So I'm quite a wee bit, as Sesame Street used to say, one of these things is not like the other, and it's me. So to give you a bit of background on, I'm here to talk about a industry collaboration initiative that we got underway a couple of years ago down in Timaru. And to give you a wee bit of background on it, the Timaru district, and indeed the wider South Canterbury, is probably well, it has got a very diverse industry sector base. We're not a one-trick pony. And off the back of that is that when we talk about the people that we need to do the jobs, we need a wide variety of skills. So that's our biggest issue down our way, and it's been exacerbated by COVID. And about 4 years ago, we went out to our industry sectors and said to them, look, what is the, if we carry on doing the same thing, we're going to get the same results here. So what can we do better together? And off the top of that, the first thing was that regardless of the industry, they wanted to talk with each other more regularly, above their competitiveness. A lot of them had sort of informal relationships with each other, but not with their wider sector. The second thing was, not surprisingly, in a tight labour market where you've got an ageing population or an ageing workforce, probably one of the lowest unemployment rates in the country, immigration settings that weren't really doing us any favours, and bluntly speaking, our secondary school students, I've had 3 of them myself come through the system, coming through our secondary school eyes wide shut around their future possibilities. And that is no disrespect to the secondary school or the wider education system. It is just virtue of the fact that, rightly so, NCA is prominent, but good, solid careers advice around opening and exposing and educating and exciting our next generation on their future possibilities. I won't open that can of worms. But, so we got our industry sectors together and we called them into a room. You know, this is transport and logistics guys, these are tradies, these are professionals, these are tourism and hospitality. And in Timaru, our food processors and manufacturers. So I am yet to be told otherwise, but I believe we have the most diverse range of food processors and manufacturers in such a geographically close location anywhere in the country. Now, you'll see them when I pull them up shortly, but you know, you're talking about the Oceanas, the Fonterras, the Sanfords, the Tallys, the Alliance, the Silver Fern Farms, the DBs, or DB Heineken from a global perspective, McCain. Yes, all your McDonald's fries are produced by us down home, so we support you in that. Now, so we got them in the room and we needed to get them trusting each other, and I think that's the thing. It's about a group of the willing, it's about trust, and it's about establishing that collaboration. Obviously, the easy one was getting them into the schools, talking about their industry sector. Long story short, that trust grew over a period of time. They were sharing things like best practice around health and safety, sharing things around training, sharing staff, transferable skills, seasonality, those sorts of things. We had them in a room, the food processors, a couple of years ago, having a drink over Christmas, and we said, right, this trust here, what more can we do? What's the next thing? And I better be careful here. Martin Baker from Barker's is the operations manager out there, and he said, well, I don't know about you guys, and all the ones I mentioned were in the room, and he said, look, I'm so busy concentrating on getting my raw product off the tree, out of the ground, through my facility, finished product out to the world, I'm doing okay with my waste. I'm hearing things I could be doing better, I haven't got the time, the resources to address that, and also he said, I don't know for a minute that my A plus your B and your C doesn't equal something of value. He looked around the room to these companies and said to them, you guys will all be all over this. Not one of them looked them in the eye. They were looking at their shoes, they were looking up here, they were looking over there, and we sat there and said, well, look, as an EDA, as an independent, what can we do here? So that's where Sustainable Attainable was born. And simplistically, we said to them, you know, we went out and said, well, look, give us an idea. We're an independent. If you've got any problems with some IP on this, tell us now. We're not going to share it with the other companies, but we will be the, I suppose, nearly used the S word. Depository is the right word, is it? Yeah, okay. For it. What is it? What's in it? How much of it is there? What do we do? What are you doing with it at the moment? And what have you heard you could possibly do with it? Really simplistic. Excel spreadsheet stuff. Okay. Now, I then spoke to a good friend of mine, Hamish Cochrane, and I said, I need someone in academia world that talks the stuff or has access to the stuff that I've got no idea on, that these guys have probably already had some contact with, because we don't want to be busy fools here. He put me in touch with a lovely lady called Bex Hurrell from University of Canterbury, and she has acted up until recently as the conduit between us and our companies and the research and development companies and entities, the universities, etc. And we now have the lovely Rae over there and a couple of offsiders of her as well. And the idea behind this was specifically around their waste. A lot of our companies were working in silos, which was highlighted by the fact of that conversation earlier on that they had around the table when they all went looking at the guy that asked the question. And it's around prevention, minimisation, recycling, repurposing, up-purposing, energy recovery, value extraction, all of those things to do with their waistline. And this is sort of in a nutshell, I refer to it as our egg timer. So these are the variety of food processors, big, small, and otherwise. The interesting thing here was I was really surprised with some of our bigger national companies and indeed some of these global companies. I thought, look, these guys are all over this stuff. They won't need to be involved in this. They jumped in boots and all because it was, A, it was the right thing to do, and B, they were part of our community. So their ability to actually be part of this, feed in what they're already doing on a national and even an international scale, and at the same time hearing from others around what they're doing. It's all right. No, that's okay. Needed to be a cracker ringtone, didn't it? So we're sitting here as the conduit between our companies and, well, I've put University of Canterbury there because it's Ria and Bex and her team. Now, over that initial period, these spreadsheets were massive. There were some gaps in it. It highlighted to us that some of these companies down here did some really good things around listing their waste or monitoring their waste streams, etc. Some were bloody hopeless, to put it mildly. And we collected the data. It was analysed. Bex, Ria went through to some of the organisations and a number of others, because at the end of the day you can be busy fools with this, and it comes back to exactly what Jonathan said. Organisations, we all do it, whether consciously or subconsciously, we operate in silos, and it's in a country the size of ours, it's terrible, for want of a better term, and we tend to end up being busy fools. So the data was collected and analysed, and the whole time we're doing this, going, righto, what are the common themes here? Not surprisingly, plastics is a big one, biological wastes, and there's a couple of others as well. Now, Callaghan Innovation, big ups to Callaghan Innovation, through Bex and Ria. There were 3 students that came in on the summer internship, so we're a big supporter of Callaghan's summer internships. And they came down and did a deeper dive into this big spreadsheet that we had, went out on site visits, they got samples, the whole works, and came back in and analysed it even further. So where we are currently at, how do I go back previous? Where we are currently at is the whole time over the last year or two has basically been doing this with this information. There are still some gaps, don't get me wrong, but through the course of this, through these contacts up here, we've identified some things that are already being done, and we've dovetailed that information into them. It is fair to say I've been told this, and I don't know how true it is, but I was told it, so I'm going to repeat it, is that, and it's no wonder our organisations up here, our academics and our research and development are excited. I've been told that never before has there been such a collaboration of such diverse same sector industry companies that we've got across here that are actually all committed to doing the right thing in this space. So they're not here to tick a box, you know, to come back to, I think Jonathan might have touched on it or someone else, is that, you know, some of those early days of health and safety, oh yeah, look, great, I've done that so I can tick a box. We as the independent basically said to them, if you're not here for the right reasons and motivated to do the right thing in the space, there's the door, don't let it hit your ass on the way out, okay? So the benefits are really obvious around collaboration, but they're worth restating. The power of many acting as one. These guys are a very tight-knit and trusting group now that are very protective of their group, and they are very vocal about their group as well. So you talk to one of them, in some respects you talk to the lot of them. This, don't get me wrong, as individual companies there's specific things that sit in there that they progress themselves. Do the right thing, I've spoken about that. Substantial database of info, very attractive obviously to R&D and academics, and that economies of scale. But look, it comes down to that. The trust is the foundation to do even more together. So these companies, when we approached them and had the conversation with them, there were some that were a wee bit hesitant and stayed outside the tent and did things on the tent that you tend to do when you're outside the tent. But over time, they've progressively come in. Okay, it is fair to say some of our meat processors down our way were a wee bit hesitant for some pretty obvious reasons in relation to some of their waste treatment and some challenges associated with that. But now there's foots or toes and legs and whole bodies in the tent. So these are just some of the things that have been identified. We had a catch up. I've just got a new staff member come on to replace my lady that was in charge of it from my side of things, and likewise Rae. There's a whole lot of other things as well, but again, it's a matter of identifying where some of these things we can get some, or low-hanging fruit I call it. I know Bex hates and Rae hates that term I use, but there's got to be some low-hanging fruit here that we can go, actually, yours plus yours plus yours, we can do something with that straight away. There's some medium-term or shorter-term, medium-term and some longer-term stuff as well. But one of the big things that has come out of this, and it comes back to, again, I keep referring back to Jonathan because everything he spoke about resonated with me, is we need a more transparent New Zealand Inc. view on our waste treatment opportunities around the technologies that are already there. We are, as a CCO of council, we have territorial authorities and regional organisations operating in silos like everyone does, and we're going, oh, we need one of those here, we need one of those here, we need one of those here. We need that New Zealand Inc. view over the top, not just from that bookend from a waste perspective, definitely from the energy perspective, and the bit that sits in the middle is around the water, but I won't open that can of worms either. So, but that's sort of it in a nutshell. We don't profess to know everything about it, but the fact is that we have got that group of companies that I showed you before motivated to do the right thing. They're around the table together, they are trusting, and they are sharing. And that's the way forward, we believe, not just for us, but for other industry sectors in that as well. So that's me, done and dusted. Hey, Gareth.
Well, most of that plastic that goes in there is a PPE supply.
Yeah.
How do other parties get involved in that if you're involved in the region? Are you open to others coming in? Or?
Yeah, I think it's we definitely are, but it's very much a walk before you run scenario. Like that group of companies that I showed you on that slide there, it's fair to say don't repeat this word, they're our biggest wasters in our area, and there's a lot of data, there's a lot of information sitting in there. But by all means, we've had some conversations with up through Hawke's Bay around how we've, that initial stage around how we've got that group of companies actually playing in the same sandpit together without punching each other in the nose. Well, it's starting with that group of the willing. But yeah, most definitely, there are other entities down our way, but this was, I suppose this was the most advanced industry group that we had, and our largest industry group when it came to waste. So, yeah. Cool. Thanks, everyone. I'll be having a drink, obviously, so happy to answer any questions. So, thank you.
Awesome. Yeah. A round of applause to our speakers tonight. Thank you so much for sharing your knowledge and time with us tonight. Really, really appreciate it. As a thank you, there's a wee token of appreciation on the table there, so make sure you grab that before you go. That was the lineup. Cool. So I'd like to thank you all for coming tonight as well. So as I mentioned earlier, this is the third in a series of events. So in March, we've got a BrainDate Health Tech coming up. So if you wanted to learn more about that, in the goodie bag that you got, there's a booklet which on the back has got our industry website page. So you'll be able to, to keep up to date with all of the BrainDates, what's happening in there. Now, if keep an eye out for an email tomorrow or the day after. I will be sending out a survey as well, just to ask your opinion, to let me know what you thought about tonight's presentations and the food and kind of just the BrainDate in general. So we do have drinks and nibbles just outside, but for those who wanted to go on a tour, I'll get Garrick from Chemical and Process Engineering and Tom from Civil and Natural Resource Engineering, just to grab these signs. And if you just want to follow them, they will take you on a tour of our facilities. The drinks will still be cold when you get back. So yeah, thank you so much for your time tonight.